All right, welcome back to another episode of Math with Mr. Young. So today's lesson, we're going to work on 8.7, writing and graphing inequalities. Our standard is 6th grade geometry A and 6th grade number sense C, and our objective is that we're going to be able to write inequalities and represent solution of inequalities on number lines. Our mathematical literacy, we have graph of an inequality, solution of an inequality, and solution sets. All right, for 8.7, writing and graphing inequalities, our success criteria is that we're going to be able to write word sentences as inequalities. We're also going to be able to determine whether a value is a solution of inequality. And lastly, we're going to be able to graph solutions of inequalities. All right, our vocabulary words or mathematical literacy. So we have an inequality. Now, an inequality is a mathematical sentence that is used to compare quantities, and also it contains these signs. So we have here, I'm going to read this to you. The first one is A is less than B because B is greater. Now the open side always goes towards the greater value. The vertex side, now remember, a vertex is a point. So in this case, there's a point right there. The vertex side always goes towards the lesser value. Okay, so we go back up here. A is less than B. Whatever A is, the value of A is less than B. For an example, if A equaled 1, that 1 is less than 2. If B equaled 2, 1 is less than 2. Okay. For here, we have A is greater than B. Again, the open side goes towards the greater value. Okay, and if A equaled 3, then and if B equaled 1, then 3 would be greater than 1. Okay, now we have this symbol here, right here, the equal sign with a slash through it. So this means that A is not equal to B. Okay, so this A is not equal to B. But if you have, let me add another one. If you have something like this where you have A is equal to B, then both values would be equal. Okay. Now here, the fourth one down, we have A is less than or equal to B. So what that means here is, let me write over here, A is less than or equal to B. So what that means here, guys, let's say that A equaled 1 and B equaled 2. Okay, now if we substitute 1 for A and 2 for B, then 1 is less than or equal to 2. So what this means is that 1 is less than 2, or 1, okay, is equal to 2. In this case, it's not equal to 2, so that'll be they're not equal. Okay, so that's kind of what that means. All right, so down here, the same thing. A is greater than or equal to B. Okay, A is less than or equal to B. All right, so I gave you guys values here. So if I didn't give you any values at all, let's say A is greater than or equal to B. So this would mean that A is greater than B, or A is equal to B. All right, so that's kind of what that means. All right, and then when you graph an inequality, okay, you're going to use a number line. Okay, you're going to have a number line. Your origin's 0 here, +1, +2, +3. Their opposites, -1, -2, -3. Now, if you were to graph this, let's say that here A is less than B. So let's say A, okay, is less than B. Then my arrow would go this way if I was graphing. Okay. So notice that right here I have an open circle. So if it's less than or greater than, you're going to have open circles. But if it's less than or equal to, then these circles would be closed. Closed circles. Okay, here's what I mean by closed circle. All right, we'll get more into that as we go forth. But for the most part, that is an inequality. I gave you guys an understanding of how to graph as well. So right here we graphed inequalities. and we'll get more into that as we go forward. And let's talk about what a solution is. A solution is an answer. A solution is an answer that makes sense. Okay, so these are either going to have solutions or no solutions. All right. Okay, so there we guys go. And just remember that any negative number is always less than 0, and any positive number is always greater than 0, and all negative numbers. All right, so I just wanted you guys to understand that. And lastly, right here, open side, vertex side. Okay, when you're using this, you're using an inequality sign right here to compare two different amounts, and you place a sign in between these two numbers, with the open side going towards a greater amount and the vertex side going towards the lesser amount. All right, so don't forget that. All right, with our first example, we're going to be writing inequalities. Let's look at our directions. Write each word sentence as an inequality. So we're going to have to write word sentences using inequalities. Okay, so right here we have 4 examples, A, B, C, and D. Let's start with A. So this one here is a number less than -4. So whatever a number is, okay, a number less than -4. So we could think of anything, any alphabet for a variable from A through Z. So let's say we could have a number less than -4. So this would be a number, a variable. Let's say C is less than, so C is less than -4. All right, remember, the vertex side always goes towards a greater value when we compare inequalities, or when we compare two quantities. And the vertex side, that point, a vertex, that vertex side goes towards the lesser value. So we have a number, whatever C is, this could be any alphabet, by the way. This number is less than -4. So there you go, my friends. We just wrote an inequality. Now let's look at B. A number K plus 5 is greater than or equal to 8. So again, a number K plus 5. So K plus 5, whatever K is, a number K plus 5. In math, the word is the equal sign. But we're not going to write that today because we're writing inequalities. So a number K is greater than or equal to. So this is greater than or equal to 8. Okay, so we're going to ignore the is symbol, or this mathematical symbol, for now, because we're writing inequalities. So a number K plus 5 is greater than or equal to 8. Now remember, the open side goes towards a greater value. Okay, so there we go. All right, so let me go further with this. What if K equaled 3? And if we substitute 3 for K, 5 plus 3 equals 8, and 8 is equal to 8. So this would mean that whatever K is, and we just made up a number, by the way, whatever K is, K could be 10, K could be 1,000, okay? But we know that it's no less than 8, or 3, I mean. So this is what it means. So K plus 5 is greater or equal to 8, right? Now C, we have 4 times a number Q is at most 16, okay? So 4 times a number Q. So when we think about this, we multiply 4 times whatever Q is. Some people write 4 times Q, but you can also write it as 4Q. You have a coefficient and a variable. When you have this, remember that you multiply. So 4 times a number Q is at most 16. At most means that it is less than or equal to 16. So whenever you hear at most, it's less than or equal to. Okay, there you go. So this is basically saying that 4q is less than 16, or 4q is equal to 16. We don't know. Whatever the value of q is, that depends. All right, but here's our inequality. And lastly, the last one, problem D. A number n is greater than 1. So a number n, whatever n is greater than 1. So a number n is greater than 1. All right, there you go. And just pay attention to those keywords and phrases. All right, so there we go. All right, we're going to be checking solutions. Now, solutions are basically answers. We're just checking answers. All right, so let's look at the directions. Tell whether the given value is a solution of the inequality. Now, we have x plus 1 is greater than 7 when our solution is x equals 8. Now, you have this semicolon. This semicolon separates. It separates the solution from the inequality. So these semicolons here, they're basically separating. Let me go ahead and break out a paper. So in other words, this is the problem here. X plus 1 is greater than 7, but our solution is saying that they say that x equals 8. All right, and it's separated by that semicolon. So we substitute. If x equals 8, we substitute 8 for x plus 1 is greater than 7. Now let's work the problem out. 8 plus 1 equals 9. And 9 is greater than 7. So, would it be true? Would this be true? Is this an inequality true? Yes. It is a solution when x equals 8. All right, so you with me here? All right, let's go to the next one. Down below. Here, again, we're going to be separating. So we have 5 is greater than or equal to z over 3 when z equals 15. So again, this is the problem here. 5 is greater than or equal to z over 3 when z equals 15. So if z equals 15, I'm going to substitute 15 for z. Okay, over 3 and rewrite everything else. All right, there's a problem. So z equals 15, so we substituted 15 for z. Now, you have to go and do some division here. How many times can 3 go into 15? Well, let's count by 3's. 3, 6, 9, 12, 15. About 5 times. So 3 can go and divide into 15 5 times. All right, so right here, now we're going to think, is this true? Is this true? Is it true that 5 is greater than 5? Or is it true that 5 is equal to 5? So what do you guys think here? Do you guys think it's a solution? Yes. 15 is a solution of the inequality. So, yes, 15 is a solution of the inequality. All right, there you go. Oops. There you go. Bring it down a little bit. So yes, 15 is a solution of the inequality. All right, so hopefully you're having some fun, and let's change that mindset. Don't think of math as it being hard and difficult, although it may be, but have fun with it. As long as you have fun with it, you'll be fine. All right, here, I'm not going to cover it now. We have 7y is less than 27 when y equals 4. So we substitute 4 for y. Now remember, Whenever you have a variable and a coefficient, you multiply. So we're saying that 7y is less than 27. So now you got to think, what's 7 times 4? 7, 14, 21, 28, right? So 28, is it true that 28 is less than 27? No, not a solution if y equals 4. All right, so it's not a solution because 28 is not less than 27. 28 is greater than 27. All right, now last one, D. We have b plus 4 is less than 6 when b equals 3. So let's go ahead and substitute b for, or 3 for b. Okay, and then rewrite everything else. So 3 plus 4 is going to be 4, 5, 6, 7. So is it true that 7 is less than 6? No, not a solution. Because they're saying that the solution is b equals 3. So it's not a solution if b equals 3. All right, so that's pretty much it. Remember to pay attention to the wording. Remember to read the number sentences, okay? And have fun with it. Don't forget to substitute for the variables and then solve, evaluate. All right, for this example, we're going to be graphing inequalities on the number line. In this case, we have the horizontal number line, the x-axis. Now, we're going to graph g is less than 2 on this number line. So, let's locate 2. Now, remember earlier when I showed you guys the vocabulary words, I said less than or greater than, you have these open circles, okay? And the closed circle is less than or equal to or greater than or equal to. So these symbols indicate that these are closed circles. All right, so we're going to use an open circle because that's just less than. So g is greater than 2. So find 2. Here's 2 on the number line. Here's my circle. Now if g here, if g equaled, let's say -1, would it be true that -1 is greater than 2? No, that is not a solution, so we can't use that. What if g equaled 1? So if g equaled 1, would 1 be greater than 2? No, that's not going to work. We can't even say g equals 2. If g equals 2, would 2 be greater than 2? No, they would be equal, so that's why we have the open circle. What about 3? If g equaled 3 and 3 is greater than 2, then yes, that makes that true. So that would mean with that open circle, all the integers to the right of 2, and that's an infinite amount. It could go from all the way to positive infinity. But that is what we did there, and that is where we graph. So ladies and gents, you just tested these and graphed it, okay? So it would be true with g being greater than 2 on the number line. So it has to be greater than 2 on the number line. All right? Let's try the next one, B. We're going to graph a is less than 4 on this number line. So let's look at the number line here. Let's find 4 less than, so we're going to use an open circle again. So we find 4. Okay, and we put 4 there on the number line. Now, all we got to do, let's say a here equaled 3. If a equaled 3, would 3 be less than 4? Yes, actually that's true. Okay. What about if a equaled 5? If a equaled 5, would 5 be less than 4? No, that is not true. So basically everything less than 4 would make that inequality true, and that's how we're going to graph it. So everything to the left of 4, and that includes all these negative integers, all the way to negative infinity, All right, so there we go, ladies and gents. We just graphed those two inequalities on the number line. You could also do this for the y-axis, the vertical number line as well. All right, our last example, we're going to model real life. So I'm going to read to you guys in verbatim. That means word for word. Sorry, guys. So the NASA Solar Probe Plus can withstand temperatures up to and including 2,600 degrees Fahrenheit. So we have to first write and graph, the second thing, an inequality that represents the temperatures the probe can withstand. All right, here we go. So the first thing we want to do is we want to go ahead and make the x-axis. You can make a y-axis if you want. It's your preference. Okay, so because we're in the thousands here, I'm going to start with maybe 2,000. Let's go in increments of a couple hundred. So 2,200. And this is going to be 2,400, 2,600, 2,800, 3,000. So I'm going to stop there. All right, so we wrote a graph, or the number line, and now we have to graph the inequality. So here's your inequality. We have the word temperatures here. Okay. Up to and including is a key giveaway too. And then we have 2,600 degrees Fahrenheit. So since temperature starts with the letter T, we're going to let T stands for temperature. So I'm going to write the inequality here. So here is the inequality. So temperature starts with the letter T. So I'm going to have T. And then right here, up to and including, that is less than or equal to. Okay, less than or equal to, and then 2,600 degrees Fahrenheit. So I'm just put 2,600. There's our inequality. So we wrote our inequality. Now we have to graph it. So let's find 2,600. Now because this is a hang on, guys. So that's Smart Shorties, by the way. They these little kids, they rap multiplication facts. They're found on iTunes. All right, so right here. So these are closed circles, greater than or equal to, or less than or equal to. So they're closed. So since we found 2,600 on the number line, here's 2,600. But this time I'm gonna have a closed circle because it says less than or equal to. The temperature is less than or equal to 2,600. Now, if the temperature was greater than 2,600, then the arrow would go right. But in this case, because it's less than, we go to the left. So this could be anywhere from, so again, just know that if it gets hotter, then this probe's gonna melt. So this probe can withstand temperatures up to 2,600 degrees Fahrenheit and less than that. All right, so there you guys go. So I'm gonna write in here this, or the graph shows that 2,000 degrees Fahrenheit is a solution. Okay, so all these guys to the left, they are solutions because they are less than 2,600. All right, not solutions are anything more than 2,600. All right, so there you guys go. And here we go, just a recap for 8.7, writing and graphing inequalities. By now, you should all be able to write word sentences as inequalities, just like we did right here. We should also be able to determine whether a value is a solution of an inequality, and also you should be able to graph the solutions of inequalities. Now, in order to get better with anything, you have to practice. All right, so make sure you guys practice on IXL and ask questions to the math gurus. I'm talking about your teachers. So ask questions, ask for help, and we will help you. Have a good day.